Okay, good evening everyone and welcome to our evening presentation, the British Tunnelling Society. Before I announce the speakers, just a note on pre-registering for these evening events. It's something the ICE now require us to do. You can pre-register with the email that you get to notify you of it, or just go onto the ICE website. So the sheet that's going around, all those that have already pre-registered, you just need to tick your name off. People who turn up and haven't registered, you can still get in, but you just need to sign on. And hopefully over the next few months, more and more people will remember to sign in, including myself online. All right. Yeah, next time. Okay. So this evening's presentation is on the Saltley Viaduct gas diversion. So we have three speakers. The first speaker is Kevin Sharkey, who will give a project overview. He is the contracts director for HB Tunnelling. Kevin is a highly experienced tunnelling professional with 20 years in the industry, working across the UK and Australia, holding senior roles at HB Tunnelling Limited, Joseph Gallagher Limited, Johnson Trenchless Solutions and Rob Carr Limited. Kevin is currently contracts director at HB Tunnelling. He leads the project delivery teams and oversees day-to-day operations of the business on complex tunnelling and trenchless projects across the UK. Kevin has delivered thousands of kilometres of micro-tunnelling installations in a wide range of ground conditions using tunnelling systems such as the Seki, Herring Connect and various open-face TBMs. Known for his client-focused approach and practical problem-solving, Kevin brings a wealth of knowledge in trenchless technology, shaft sinking and project delivery. And the second speaker is David Mumford, who will be talking about the geotechnical and design aspects of the project. David is a technical director at OTB Engineering. He's a chartered civil engineer with over 15 years design and consultancy experience. Since joining OTB over 7 years ago, he has been responsible for delivering a variety of geotechnical and tunnelling solutions across multiple sectors in both the UK and internationally. And the third speaker is Hugh Early, who will be talking about actual delivery of the project. Hugh is a senior project manager with HB Tunnelling. He is one of their most experienced project managers with over 15 years in the construction industry, specialising in shaft sinking, micro-tunnelling and trenchless solutions. Over the past decade, he has delivered key infrastructure on major programmes including HS2, Tideway and Crossrail. Hugh was the project manager on the Saltley Viaduct gas diversion for HB Tunnelling, and his leadership on high-value, technically challenging schemes highlights his expertise in delivering efficient and safe trenchless works in urban environments. Okay, Kevin, please.
Evening all. As John touched on there, I'm Kevin Sharkey, Contracts Director for HB Tunnelling. So I'll give a brief overview of the scheme that we've just delivered back end of last year, which was a Saltley Viaduct gas pipe diversion. So in this presentation, we'll run over the project background, general site constraints, geological and geotechnical risks, design, method selection, third-party approvals, settlement monitoring, impact assessments, construction phase of the project, along with the construction, and then a conclusion then at the end of the presentation. So project overview. As part of the HS2 works, Balfour Beatty Vinci's JV, they're required to demolish this existing viaduct in Saltley, just south of Birmingham. So as part of that scope, there's a 450 mil intermediate pressure pipeline that requires to be diverted to move it out of the way for the future viaduct infrastructure and to relocate for the HS2 works. The pipeline will cross from east to west underneath the the Derby and the Westwood Heat train lines. So obviously this needs to be constructed via trench technique, given the constrained environments within there and how busy that section of South Birmingham is. So at the beginning of the project, when we were engaged, we were given 2 sites, very constrained, 2 specific locations. So one east and one west of the train line. So obviously the west one, which would end up being the reception shaft, and the east side, which would have been the launch shaft area, given the size and location of the areas that we could set up our equipment in. So on this project, the pipeline itself was a Cadent Gas pipeline, who engaged United Living as the principal contractor. In turn, United Living engaged with ourselves, HB Tunnelling, as the preferred supplier to undertake the works on this. Within this scheme, HB Tunnelling were given the design and construct of the actual tunnel itself underneath the railway line, the CEM, the CRE for construction role, and also the CRE for track. During this phase, we engaged with OTB as one of our preferred design consultants to work alongside us and deliver this scheme. So they worked as our design partner and also undertook the CERE role for the design. So initially, what we needed to look at was the constraints that we'd have to work under. So we undertook multiple site visits along with our clients, Cadent, United Living, and came up with pretty much 4 main constraints that we'd have to work with. Obviously, 1 being the live railway. 2 then was our third-party interfaces with a canal, a live HS2 site that we needed to work within, both sides of the railway, highways, viaduct, and also the HS2 new viaduct piles which had been installed prior to us coming to site. Restricted access was one of the big ones on the reception shaft side under the existing viaduct, and also then with the initial information that we had for dewatering and contaminated water, contaminated material within the ground geology. So the site constraints were here as shown. So obviously we had the live railway line, so we needed to design the UTX. It was under 5 tracks. So it was the Derby and Washwood Heat train lines, very busy train lines in and out of Birmingham. The track support zone was also one of the other constraints that we tried to stay outside of, which was very tight, as you can see here at the reception shaft. We were just outside the track support zone with the shaft construction. There was a pod track system to be installed to allow us access from the launch shaft side across to the reception shaft side, but due to the fast moving nature of this project and the approvals for HS2 and Network Rail, this system couldn't be put in place in time to allow us access, which meant we needed to bring everything in underneath the viaduct access here. So on this one here, you can look, this is pretty much the reception side. So we didn't get the access across here due to the time constraints. So we had the low level arch to deal with. We had the Network Rail boundary wall that we couldn't go near. We obviously weight limits on the viaduct bridge itself, when we looked at actually potentially looking at craning material and planting. The close proximity of the River Ray was also, given it was a very old asset and it's a brick wall, and obviously a lot of monitoring was carried out on all these assets pre, during and post the works on site. So given the lack of access on the pod track system, we had to think outside the box, and this was all ongoing during the design phase. So we had to bring everything that we needed to install the shaft in underneath this bridge arch, which we got a 3D laser scan done, very tight. So we actually had to, it was that tight, we had to actually do trial runs prior to us getting access to site, which we agreed with BBV under their CDM. So we had to do trial runs, get cranes in and excavators, given that the reception shaft was going to be circa 15, 16 metre deep. So we needed some substantial plant in there to construct it because of the contaminants in the ground due to the groundwater being having hydrocarbons in it. So one of the other constraints is obviously just touched on there was the hydrocarbons. So there was no allowance for dewatering, which we needed to take into consideration in our design. There was no discharge points available. Obviously no time to get the consents for abstractions or recharge licenses. So that brought us in then to what we could actually build feasibly, safely, and within the time constraints. So we ended up looking at the shafts, thinking as a wet Caisson method, and looking at the TBM selection, which we ended up looking at a closed face slurry machines, which Hugh and David will touch on later on in the presentation. So that's pretty much a lot of the size constraints that we were up against at the start of the project, which then we had to adapt and bring into our design development along with OTB and our clients. So let's play a short video now, just an overview of the site, give you an appreciation of the type working area that we're working in, and then I'll hand you across to David then, who'll bring you onto the geotechnical side of it and the design development.
So yeah, the site presented some challenging and potentially problematic ground conditions with just regional geology comprising made ground over glacial fluvial deposits, shown up here, and a alluvial channel followed a river which has since been canalised and diverted. The underlying which was the Sidmouth mudstone formation under the UTX location, and 150 metres to the west there's a fault running approximately north-south, and the Halsby sandstone formation. Now our site in particular found that the glacial fluvial deposits were actually within a historic deep channel, and see the red dashed lines there is approximately where our site is, which meant that it was potentially for sort of rapid changing rock head, and the glacial fluvial deposits themselves are water bearing, comprising dense sands and gravels and potential cobbles. So the geotechnical risks are fundamentally the potential for running sands with high permeability and possible fast-flowing groundwater. There was a rapidly changing rock head, posing a risk of potential of whether the shafts and invert could hit that rock head. Potential for cobbles and boulders within the glacial fluvial deposits and contaminated land due to the historical industrial activities at the site. There's actually quite extensive ground investigation undertaken across the site as part of the HS2 project. Only specifically where we were for our site, rockhead wasn't proven, and the boreholes that were undertaken just to the north showed them at significantly deeper than the boreholes at the south, which showed them around about the proposed alignment. Consequently, we undertook some additional ground investigation alongside the design as the design progressed, as confirmatory holes to sort of validate our design and de-risk the construction. Because, as I say, there was plenty of ground investigation across the site, enough to progress the design, and the programme meant that we really had to sort of crack on with the design and do this concurrently to provide the sort of validation. 2 boreholes were undertaken, as I said, and proved rockhead to be actually 10 metres below proposed invert level, as well as providing sort of valuable information around the groundwater flows and the contamination at the site. Using the information available as well as the additional information that fed into it, a GBR was produced by a third party to maintain sort of independence and fairness to all parties. I think it's fair to say all parties agreed it was a reasonable and fair GBR. So the solution itself, first of all, with the pipe jack itself, I think initially 900mm ID pipe was proposed. However, considering the various factors discussed above, the potential mixed face conditions, the potential requirement for accessing and getting in there to deal with any breakages, as well as assisting with the annulus grouting and accuracy with that, and and just general, the settlement controls with that. It was actually upsized to a 1200. And then the shafts themselves. There's a 7.5 metre ID launch shaft that was driven by the product pipe, so it could be installed in longer sort of 6 metre sections, and then a 5 metre ID reception shaft, both of which comprised of segmentally lined FP McCann shafts, installed as a wet caisson with a back wrap. Once at depth, it enabled the installation of the plug, dewatering, and then grouting. As I say, the machine that was used was a 1200 AVN Herring Connect machine. Closed face enabled us to manage volume loss and control ground movements, obviously with sensitive overlying railway. It's a bit more about the shaft construction. As I say, the shafts were positioned outside the track support zone, thus sort of mitigating the risk and approvals, third-party approvals required by Network Rail. They were temporary to be backfilled following completion. Yeah, as I say, back wrap to provide that additional weight to manage flotation, as well as help with water grouting, and when it came to the launching of the TBM, enabled segments to be removed and risk of sort of collapse of the face mitigated. And yeah, as I say, head and thrust walls, cages were all installed and then labelled, the rings to be broken out and launched. The pipe itself, again, standard FP Buchan jacking pipes, designed to accommodate sort of full overburden and track loading. Pipes installed, annulus grouted, following which the product pipe could be installed and voids grouted. So obviously with the sensitive overlying infrastructure, undertook a ground movement impact assessment on the railways, railway lines above. This sort of confirmed the initial assessment that was done to determine the depths, and locked in the fact that we're achieving a theoretical settlement of less than the 5 mil limit set by Network Rail. There's a little bit more later on the track monitoring and the performance of that, and the comparison between predicted and actual experience. As I touched on sort of previously, there was really tight time constraints with sort of identified key construction periods. So the assurance process, with the way in which we selected the methodology, undertook the concurrent design and confirmatory sort of validation, ground investigation, it meant that we could expedite the approvals process and manage the risks with Network Rail safely. As I say, removing the shafts from outside the track support zone, remove them from the Form AB process, so it could just concentrate solely on the tunnelling and temporary works. And yeah, I think it was all done and sorted within only a couple of months. Ongoing regular engagement with Network Rail was sort of critical with that. I believe that is me.
Hi all, so I'm Hugh Early, the project manager who delivered the scheme up in Saltley. So, as touched on earlier, there were 5 of these tracks to go underneath, so we had early engagement with Network Rail, Cadent early on to go through this and get the monitoring plan in place. So possessions were granted for vegetation clearance and surveys. We had only small, short 6-hour windows to get these done every second weekend, so we were up against it from the start, but we got there for the pre-trend surveys. All 5 roads had targets installed for monitoring pre, during and post the works, and during the whole tunnelling sequence 4 mil vertical settlement was noted, and we think discussing with BBV and Cadent, this was due to the tamping trains during the works. That's just the overview that was here earlier on. So launch shaft down here, 7.5 to the 5 metre reception, 108 metres long tunnel, 1200 ID. And there's a future Cadent works here, open cut to continue the gas pipeline. This was the reception shaft shown on the left, and 7.5 metre launch shaft here. What are 3 sections of 3 number arrays of for monitoring points. This is a large capping slab that was BBV installed. Line of piles down here as well for the future works coming through. Targets on the track, 5 metre centres, 30 metres either side of the centre line. These points were monitored on approach to the track support zone by the subby we had used. So 1 mil was noted during the TBM launch phase just before the track zone, and we were in daily meetings with the CRE and the Network Rail prior to continuing, so all went well underneath the railway. Just the long section showing what we just discussed there. So outside the track support zone, close proximity to the Network Rail wall and the 5 lanes, so 9.9 metres cover to the top. The instrument monitoring plan, so this was carried out by the subcontractor, obviously for the baseline before we started. During the works was 24/7, 4-hour intervals, and then week 1 and 2 was following the works daily and twice a week. Week 3 was twice a week, and then week 4 once. So from October 24 to December 24, when the tunnelling was taking place. These were just the parameters from the track monitoring plan. So green trigger levels, -5 mil, amber -8, and the red -10. So we've only ever went up towards the -4, potentially due to the tamping train, as discussed earlier. All of the readings were fine during the daily meetings we had with the surveyors and HB and Cadent and Network Rail. Just a few photos of the install and the instrument being used to carry this out. Sample of the track monitoring sheet, so all readings were within the tolerance throughout, and post the UTX crossing, no worries. 4 mil vertical during the drive was noted. These are just a selection of some 3D models we had done up. So again, launch shaft 7.5 metres across to the 5 metre reception. Shaft sinking down, and this is the reception side, launch side with the jacking rig going under all 5 rails. There's a bit of a model video just to play. This was towards the end where the client were installing the gas pipe down into the shaft. So this was the 450 gas pipe, and welded in 6 metre lengths by United Living, and was pulled from the reception shaft up through the tunnel on spiders. And after that work was complete, then we'll touch on it later, we grouted the tunnel annulus with a specialist subcontractor with a SIBO kind of grout, Cadent approved mix. So just going under the washwood and the Derby lines here over to the reception shaft. There's the narrow arch that Kevin touched on earlier, and the weight restrictions on the bridge, so that dictated the plant we could use here. And again, United Living pulled through the 450 gas from here once it was welded in the reception or the launch shaft. So like Kevin and Dave touched on earlier, very close to the track support zone, both sides. 1 mil displacement was we monitored prior to getting up to this point, and 4 mil throughout the whole drive. So the construction phase, we'll touch on collar work, shaft sinking, contaminated ground, and the base pour and grouting works. So due to the dense ground, we had to do some pre-augering at both shaft locations. So 7.5 metre shaft was drilled to full depth, 750 diameter augers. Obviously entry wasn't possible into the shaft due to the wet dig methodology, so we went with this to loosen up the ground prior to shaft jacking. So some photos showing it. into collar excavation then on the left hand side. First photo of the launch shaft, 7.5 metres for cutting edge and ring building, blinding works, and setting up the first ring on top of the cutting edge. So the cutting edge was obviously made to have the backrap shutter on it. 300 mil thick was the first pour, and then it tapered into 250 for the rest of the pours, the full depth. So 7.5 metre backrap was constructed by Strain Engineering, made up in their yard. Ourselves and Cadent went up, done a factory test with them. All was good, and it was disassembled and brought to site. So here's just the first one poured, the 300 mil poured, and the backrap removed prior to Jackson's installation. So these were the drawings from Strain. So the first one was a 850 deep cutting edge, 550 wide, so you could have your McCann segment, your first 300 pour, and then the backrap at the back of it itself, angle brackets to hold it, and I would step into then the 250 one on the right hand side. So there was little joints to hold these together. You would take out the joints to get it down to the 250 sections. Photos of the long reach shaft jacks to push it down to go over the top of the backrap shutter. This is the backrap installed on top of the collar. Here it is poured, so we would get 1 pour a day at each shaft due to the backrap constraint, where we had to pour towards the end of the day. Approved concrete mix and accelerant in it, and we would get some results the next day by the lab who tested anything over 4 newtons. We were good to push the next day. All results were in the 5, 6, 7s, so we had no issues going the next day to keep on programme. Obviously these are just the shaft jacks. They reach over the top of the backrap shutter, push it down, so the ring on the inside in the previous day's concrete gets pushed down at the same time, and the backrap stays on top of the collar. Shaft jacks, 40-ton jacks with the backrap sitting in place on the collar, some just strengthening bars to hold it as well. And here was the concrete we poured every day towards the end, installed, pokered, 1 wagon per day on both shafts to maintain ring building every day. 35-ton telescopic shaft excavator was digging on obviously wet dig underwater, so long reach, muck shifting by the excavator up and stored on site here by the client United Living for treating and getting off site. Contaminated ground was picked up on earlier, so a range of oils, diesels, hydrocarbons were present. So shaft water in the end, once we had the shaft constructed, United Living had to get this tested. We had to pump it through a chemical dosing unit and through silt buster unit into large 30-metre tanks before they had approval to pump it into the network once testing was deemed sufficient. No pumping was due at the reception shaft, like Kevin said earlier, so they had to tanker it off-site at the reception shaft, and contamination started circa 3 metres below collar level on both shafts. Some photo, oily hydrocarbons, bad smell off it at the time. So once that was done, we obviously the plug was poured underwater using the concrete pump to ensure even distribution. Plug was left for 4 or 5 days to cure, had to reach 20 Newton of the 40 specified, 50%, prior to pumping out the water. Getting on with the base and the dowling works. Just a photo, this camphor pump underwater, Tremie method, right down to the bottom and moving around and lifting up in stages. This was when the shaft was being pumped down into the silt buster and chemical dosing unit, large holding tanks, and then pumped into the network. Then obviously when it was pumped down, we just target grouted where there was small leaks in the shaft rings, forcing the lubricant to the collar, which we disposed of off-site. Onto the base pour then, so setting up the steel, dowels, hydrophilic strip before we set up the tunnelling rig for the jacking rig for tunnelling. Just a photo of the concrete being poured. This is the chemical dosing unit and the silt buster, so we'll go into this and get screened down into the dosing unit, into these large tanks, and then the pipework ran down the back of the site and up towards the existing manhole on the BBV entrance. Then we're into the separation plant and centrifuge stage and setup. So desander unit and centrifuge, crane for obviously lifting in and out the jacking pipe, setting up. Separation plant and centrifuge setup. So we had obviously the primary desander, hydrocyclones and screens, remove medium-sized particles, sand and silt up to 20 to 74 microns. So it goes through the core screen. The first stage passes through core screen, intercepts large particles and debris. In the storage tank, the screen slurry collects in the tank, ensuring a consistent feed. Dewatering screens then separate solids or discharge onto screens, which remove excess water, resulting in the drier soil. And then the clean slurry return is reused in the drilling or further treated. And then the centrifuge then remove the fine particles. Slurry flows into the high-speed decanter, centrifuge or bowl. Rotating bowl generates high G forces. Heavier solids are flung out to the outer wall and discharged separately, and the cleaner slurry exits through different ports with the minimal solids. This is just the TBM Lorena, named after the United Living's project manager's daughter. A little video of it being just lowered into the launch shaft. Once the TBM was through, so about 108 metres of a drive, pipeline install, 6 metre lengths of gas pipe were welded in the 7.5 metre shaft pit bottom by the client United Living, pulled through on rollers, as mentioned earlier, towards the reception shaft. We installed these blue 63mm HDP pipes into the 12 o'clock position of the jacking pipe to grout the tunnel at a later stage with the specialist subcontractor we used, Bentonite MS. The approved Cadent mix. It's a bit of a programme of the job. So we started ground investigation in GBR, May, June 24. Design, same period. Forms A, B and C, like Dave touched on, we're quick to go through the process to get up and running. Safe steps of the work. Launch shaft started in September. Tunnel in October into November. Pipe install November, December, and then grouting and backfilling the shaft. So just a photo of the TBM when it's come out. So shaft sinking, we average 1 ring per 12-hour day shift due to the back wrap requirements. So that went well. We got good supply of concrete up there. Tunneling, average 20 metres per 24-hour shift. TBM within 5 mil when retrieved in the launch shaft, or reception shaft, sorry. And the max jacking pressures were 110 bar throughout the drive. So it was I think 12 shifts overall, 6 days to start to end. This was the grouting then of the tunnel at the end. So once this had been gone through, we engaged Bentonite MS to fill the tunnel, the gap between the 450 pipe and the concrete sleeve. So we had to get to between this approved cadence, so the density between 1,000 and 1,400 kilogram per metre cubed. 1 MPa was the target strength at 28 days. We had over 1.5 on this. It's like a weak mix, and we installed 1177 kg. Tunnel fully grouted over 2 shifts. Cadent gas pipe here. This was our filling ports. We had 2 or 3 bolted to the top of the tunnel for filling up, and then cathodic protection and United Living fixtures inside as well. Just a little video of the pre-augering. So the ground was very dense and obviously contaminated that the client had to deal with in their storage areas. Collar, some shaft sinking, the pour in the back wrap, and excavating the shaft with the telescopic grab. Back wrap shutter installed and keeping the pressure on it. Underwater dig with the telescopic excavator, hydrocarbons and oily diesel. So we had to open the bucket slightly to let all the water drain out and then get the material into the holding places. There's the TBM just been lowered in. during this we had several visits from HS2 and the client Cadent board, so all very happy with the job and the setup. There's a bit of a summary at the end. So the job went accident and incident free, no issues on the job, delivered ahead of programme. Client were very happy, Cadent and United Living. Risk of contaminated ground was mitigated. Geotechnical ground risks were mitigated by the technique selection. No interruption to HS2 works and the railway during our works. Loss of track crossing point overcome by adaptation of plants. So due to the pod track system not being in place, we had to go under the arch and laser scans, etc. that Kevin touched on. And yeah, no damage to third-party assets. Yeah, that's it. Selection of photos.
All right, thank you very much. I'll take some questions, please. Yeah, Mike, we've got microphones, please. Yeah, just down here.
Mike McConnell, retired from Beltrabidi. Well done, Kevin, David and Hugh. Quite a job with, in fact, the whole job really is about risk management, as I see it. Yeah. And Kevin, you had mentioned that it was a design and build contract as such. I just wonder if you can elaborate on that design and construction aspect and the management of was it a pain and gain situation overall then on that risk management? And in retrospect, was the pain and gain seem to operate fairly okay? Because the other thing that worries me is that when you start designing a job, is that you're only getting an awful lot of the SI at the time of actually happening, as it were. So, I mean, it must have been quite difficult at tender stage, actually making a lot of these decisions, because it seems to me that a lot of the SI was coming progressively through, as it were, and how that particular risk was managed in the pricing of it. I know from an estimating point of view, that must have been an interesting job to price. So I'm sorry I've gone through a number of questions there, but I would just be interested. That's just the thing that first hits me, as it were. Thanks very much.
We were engaged obviously early doors, given the tight time constraints. So between ourselves and our client and Cadent, we came up with some assumptions in regard to the pricing of it. So we came with a baseline of assumptions. It was priced on that assumption. There was quite a lot of GI there, so we based it on the GI that we had and the assumptions that we made at tender time. Obviously, the additional GI was just for validation. So we came up with our price, agreed the price with the parameters there. Once there was some minor changes. To be honest with you, it didn't change a lot compared to what we'd assumed. But we then done a CE variation of the contract on the minor changes, and we completed the project on that basis.
Was there an actual pain and gain mechanism?
There was no pain and gain
contract.
No, there's no pain and gain mechanism in the contract. Lump sum.
Well done.
Okay, yeah.
Hi, Thomas McGowan, Betty Consulting. Thank you very much. It was a very interesting presentation. First question for Hugh. The jacking force was listed as 110 bar. I guess that's the hydraulic pressure. Would you know what the force was in tons or kilonewtons? And then second question for David, if you know what the thrust ball was designed for. Thank you.
Not to hand to them, I don't know about that.
No, sorry.
Okay. Off the top of my head.
No problem, thank you.
Yeah, sorry, I can answer that one. Yeah, so the maximum jacking force that we came across on that tunnel drive was 180 ton on the tunnel drive, and again the jacking wall was designed for 340 ton.
Got a better memory than me.
Andrew Smith, like Mike, I'm also retired. 3 questions. Can you explain why you jacketed the shaft? Is it to facilitate the construction of the eyes at the bottom, or is there some other reason? Second one, because it's backfilled, are the pipes part of the permanent design? I wasn't quite clear about that. And thirdly, these are all different questions, you were excavating shafts in contaminated ground underwater, so how did you get rid of the material off-site because it was contaminated?
Yeah, so the first one, the back wrap shutter, was used because we're launching the TBM out. We didn't want the ground coming in, and it added for weight as well, for flotation.
Yeah.
So that worked very well, doing it 1 ring at a time, obviously every day, so it worked good. What was the second question again, sorry?
About pipe design. Pipe design. Being part of the permanent works.
Permanent works for Cadent,
Even though they were backfilled afterwards.
Yeah, part of the permanent for Cadent, and they've obviously broke the collar to put in their new 450 pipe, and digging underwater, the client, United Living, were doing that, so we separated on site, and they had various rounds of testing and EA coming in, and additives added to the ground before mucking away off site.
Is that including the shaft muck?
Yes.
Right.
Yeah, shaft muck and tunnelling, yeah.
Thank you.
Martin Knights, LBA. I think David described the JBR as okay. So what was good about it? And did you exceed any of the baselines?
I think what I meant was it's sort of like fair for all parties. I don't think it was the parameter. I think due to the level of information and ground information that was actually there, it meant that you could have some reasonable ranges that just shared and distributed the risk between the us or HP and the client reasonably well. So, yeah.
It's the first time I've heard a GBR was okay.
I've got one online here first. It's from Harsh Patel. What was the clearance of the tunnel's face from track support zone?
It was about 42 metres to the start of the track support zone from launch shaft.
Thanks. Yeah, at the back.
Paul Perry from AECOM. So if I understand this right, your instrumentation monitoring, all you required to monitor was the, as you show in the tunnel, they didn't require you to monitor the shafts. And essentially, your baseline monitoring was 1 month beforehand. And then you carried through it, and 5 mil is a good prediction, and 4 mil is even better. In your experience then, is this the norm, I&M, for this type of thing? I mean, normally what people do demand, of course, is a bit longer than a month in terms of baseline. But then maybe you predicted from your results, David, that 5 mil was going to be the outcome. I'd just be interested in your thoughts on that.
Yeah, I think the ideal is to get as much as they're willing to pay for. A full 12 months as a minimum, so you've got the full seasonal variation, is obviously ideal, but as we sort of said, the programme and how constrained it was, you get to a position where you basically get the baseline that you can get to hit the start of the programme. So yeah, and I think due to the depths and the controls that we had and the volume losses that we chose, I think sort of demonstrated theoretically that the risk looked pretty low, and that sort of confirmed with the monitoring.
So on that basis, you didn't have to monitor for shaft excavation construction?
No, it was that was outside the track.
No, yeah, we had some pins around the shaft and the collar just for ourselves, but the array of 3, we only had 1 mil coming up to that 42 metres before the track support zone, and then 5 mil overall. And
you just declared the instrumentation associated to the track support zone. So in terms of an overall cost, and coming from AECOM, because we write spons, we're quite interested in these things, What sort of percentage cost of this? Was it relatively small beer for the overall contract? If we could have the exact values later, that'd be really good. But,
We'll take your email address.
that's excellent. I'll talk to you later. But I'm assuming it was small beer, really. It was less than 10%, less than 5%. Not even that.
Yeah, less than 5%.
I'll talk to you later.
Any other questions? One from me. So, from what you've told us, and that everything seemed to have gone really well, you planned it well, and it was delivered well. 6 days to do the actual jacking was fantastic. Would you do anything different?
Not particularly on the scheme, as I said. A lot of schemes you'd only go 24-hour tunneling once you're in the track support zone. But given the small length of this tunnel, we opted, and obviously with the programme constraints, we opted to go 24/7 right away, which allowed us to get that tunnel from start to finish within 6 days or 12 shifts.
Yeah. Okay. Another one online. This is from Spandan Banerjee. Any vibrations and settlement issues? Can we get the presentation slides if there are no issues?
Yeah, the client was in charge of obviously the vibration of the river walls, the network rail wall, all within the parameters. No issues to report. Yeah. So and then obviously 4 mil on the tunnelling. All that's planned.
Good. Any other questions?
Oh yeah, sorry, I might have missed this. What's happening with the top of the shaft? Is it just being a cover slab on it and then left like that, or is it landscaped or anything?
So these are just random photos from other jobs.
All right.
Yeah, so just to answer the question there, no, the gas pipe was brought up and taken out circa 2 metres below ground level, so the top 2 rings were removed and the whole shaft was backfilled.
Okay. Thank you.
Any more? Okay, another round of applause for our speakers, please. All right, just a few slides and then down to the bar in good time as well. So, yeah. So yeah, food and drink sponsored by HB Tunnelling. Thank you very much for that. If you don't know, you only need to queue for the food. The beer is if you just want beer, but you can do both. You know. A couple of things here. Then I mentioned about pre-registration. This is what the IC now require us to do. If you missed it earlier. I think about 22 tonight have pre-registered. We just need to get into the habit of doing it. But you can still turn up unregistered, but you have to sign in. But the preference is you pre-register. Our next meeting is in May, and that's our annual general meeting as well. So the AGM papers will be emailed to members in the coming days, anything you want to raise then. And every year, 3 elected members drop off the committee and we bring in 3 fresh members from the society. So anyone can nominate themselves with 2 society members. So this year we've had a really good number of people putting their name forward, more than 3. So that will go to a vote. All society members will get an email and you'll get a selection of people to vote for. And the successful 3 will be announced just before the AGM. Okay. So yeah, the vote is coming out on the 24th of April. All right, our May meeting is on the Heart Project, just recently been awarded. So John McNeil and Nick Sharwin, both from the client there. So it should be interesting to hear about that project. Massive one. The May workshop, Connecting the Dots, Tunnel Engineering and Knowledge Framework by C. Shen. The bit that I liked was the bit near the bottom there. It will be free from equations. Only common sense is needed. There you go. And that is on, the 15th of May. So I should look at these. Annual dinner is 6 weeks away tomorrow. So on the 23rd of May, I think we're on about 63 or 4, Divik, is it? Tables?
Yeah, 64.
64 tables. So there's a few left. Is the website sorted now? Does it shows you can still book, doesn't it? You still book tables, or you can book as an individual. Concession rates for retired members, and everyone is welcome. A few more left there. It's not on our normal first Friday in the year. It's the only one we could get for this year, but next year we're back to the first Friday in May. All right. So the bottom level is fully taken, and there's a few tables left on the top level.
That's 5 more gone since earlier today as well on that
5
top
more
level.
tables.
So they're selling out fast.
Yeah, yep, getting quick. And individuals are very welcome as well. Divik does a good job trying to pair people up and that. Design and construction course. So always very popular. This is at Warwick University. We always get great feedback on this. Leading experts from the industry giving lifetime of knowledge to people. And it's a bit of fun as well. There's evening sports events. There's an evening dinner as well with a guest speaker, which is Helen Natras this year. 30th of June to 4th of July, Monday to Friday. Booking open through the BTS website. So young members, the Doug Allenby Memorial Award. So Doug's widow left the sum of money. This is to encourage young members and recognise their achievements. So it was awarded for the first time last year, which was lovely, and that was awarded by Doug's widow. And then there's 2 £1,000 bursaries available for young tunnellers to attend the World Tunnelling Conference in 2026. So if you know of anyone or you want to nominate yourself, go through the website or any member of the committee. Another one for the young members. So their conference is on the 24th of October, which is normally at the Arup office. Yeah, it's at the Arup. I went last year, it was very good. And any companies that would like to sponsor it, they'd be very keen to speak to you. So the book, or Mike is really fostering this. Mike, who answered the question, or asked the question earlier, has been round to 5 or 6 universities so far presenting the book. Queen's, Southampton, that's Imperial College, and we're looking at Nottingham as well, Exeter. It serves 2 purposes, really. It kind of shares the knowledge of tunnelling to students, and, 3 purposes. Encourages them and hopefully motivates them to come into the industry, and it also helps forge links between the Tunnelling Society and the universities, which can only be a good thing. So anybody who would like to go back to their old university, we can donate a book to do that. I think we're at the end now. Yeah, there are still a couple of books available to buy on the website as well. All right. Thank you very much.
And whoever has the sign-in sheets, if you can bring them in the front, that'll be much appreciated.